Assalamu alaikum warahmatullahi wabarakatuh. My name is Awad Al-Maashi and my friend Talal Ghamdi.
In this video, we'll talk about electric motor improvement steps.
We have prepared a short story about electric motor.
So please watch this video.
Today, that new competitor is still with us. We don't have steam engines in our houses, but we do have lots of electric motors. Look around your house, it's loaded with them. Electric clocks, air conditioners, CD players, VCRs, fans, vacuum cleaners, blenders, and of course, who could forget the electric toothbrush? They are all powered by electric motors. And today,
Without it, we wouldn't even be able to sit here and make this interview. It wouldn't be worth getting out of bed unless we wanted to be back in the horse and buggy days.
unlike most engines, which use some kind of combustion to create heat, the electric motor is powered by an entirely different principle. It's based on the fact that when electricity flows through a wire, an electromagnetic field is created, which means you've temporarily turned that wire into a magnet. Turn the electricity off, it's not a magnet anymore. Hook it up the opposite way, and its north and south poles reverse. An electric motor does this over and over, using the magnetic force to create motion. Of course, electric motors need electricity, so their history begins with the earliest electrical experimenters. In 1824, Michael Faraday patented his direct current, or DC motor. In 1888, the eccentric genius Nikola Tesla patented his alternating current, or AC motor. Today we use both. If it runs on batteries, it's a DC motor. If it plugs into the wall, it's an AC motor.
Tesla was the first one who introduced it. The concept of alternating time, where we would change the battery back and forth as 60 times or 50 times a second. As it was, and Edison didn't believe in that, and that naturally fired Tesla, and that went to work for George Westinghouse. Tesla was right. Alternating current could be transmitted over miles and miles, and there were significant limitations for the direct current transmission.
George Westinghouse acquired the patents for Tesla's alternating current system, and in 1891 installed the world's first high-voltage AC transmission line in California, connecting San Antonio Canyon with Pomona and San Bernardino. In 1894, Westinghouse began manufacturing another one of Tesla's inventions, the AC motor. Early electric motors were used to power some of the very first cars, along with steam engines and internal combustion engines, which used an ignited fuel like gasoline to propel the piston up and down.
I don't think anyone knew, at least for the first decade or more of the autumn, always existed in this as to who was going to wait out.
Around 1912, the internal combustion engine finally did win, ironically because of the addition of an electric motor. It was called the starter. And it did just that, getting the pistons to start firing without throwing the driver's back out, or worse.
Up into that time, you had to count an engine to get it started. It was not only difficult, it was dangerous. It could take your real brake bones, and you are one of those things jerk back on you. You could really hurt yourself. But was the electric starter that changed the whole ballgame and immediately signaled the demise of both the electric.
Like the hand crank, the starter's electric motor initiated the compression and combustion cycles necessary for the engine to run on its own. Some of the largest electric motors have been made for use in elevators. In 1933, Westinghouse built the world's fastest elevators for New York's Rockefeller Center. In In 1972, Westinghouse installed the elevators in what was then the world's tallest building, the Sears Tower in Chicago. In the 1990s, the electric motor made an automotive comeback when General Motors introduced the EV1. It was extremely lightweight with a strong, rigid frame and one of the most aerodynamic car bodies ever made. Some said it was built more like an airplane than a car. The highly advanced EV1 was a flop, and GM canceled production in 2000. As with all electric cars, its biggest problem was limited range between battery charges.
If you are in a hurry to go someplace and you can only get out of miles, you have to stop 8 hours to charge. I mean, you might as well have a covered wagon. I think it's unlikely that in the next 10-20 years, electric vehicles will compete with standard cars. Battery technology is just not good enough, and these batteries are expensive. Once you take them up to the scale that you need to store enough energy to drive a vehicle now, if they get a bit smaller and we are willing to have a limited range, it might be that electric vehicles will be interesting because they really would have no emissions where the car is being driven.
Electric cars may not pollute when they're driven, but there's still pollution where the electricity is generated to charge their batteries, since most of it comes from power stations that burn fossil fuels. Because electric vehicles require either batteries with limited range or overhead power lines they can hook onto, they've been more popular for public rather than private transportation. Cities like Los Angeles got their first electric trolley buses in the early 1900s, and some cities still have them. Virtually all subway systems and light rapid transit systems use electric motors. And just why do we call them electric motors when we call the other machines that power our lives engines? Well, that's a matter of debate. And it's a debate that can keep scientists and engineers amused for hours. They sometimes refer to it as the great engines versus motors debate.
I don't think there is a clear onset. Technically, we use the word engine for a device that takes energy from some source, like fuel, and convert it into power that we can use to drive something. Engines versus motors. In my personal opinion, I think that an engine, when I think of engines, I think of heat engines. I am thermodynamic system. We talk about heat engines. There are many contradictions even within the industry with regard to nomenclature. The things that I would not recall motors as opposed to engines would be firstly things like electric motors.
And how do you explain outboard motors, which almost always have engines in them?
A very good question that I never said we were constant in how we use those words in the automotive industry. A motor is an electrical machine. An engine is an internal combustion machine.